Hello and welcome to the April Q&A update from the Tau team. So without further ado, let's get into your Q&A questions. So the first question is from S. Nixon, and they ask, if you could compare where Agoras are right now to another crypto or even an S&P 500 company was a few or several years ago, which company would you choose and why? I would choose Google. And the reason being is because Tau, at least in my opinion, represents one of the greatest expansions in the capability of software and also the gold standard in how software will be created in the future. And we've discussed this many times, but the software sentences alongside logical creation of software, massive embedding in the power of mechanized reasoning within software. So I think once we have a lot of software that's using either Tau's development methodology or just using a lot of the features of Tau, I think we're going to see a massive, really different landscape in terms of what software will be like. And the next question is from S. Nixon, and they ask, if Agoras can live up to the potential and ambition of its developers, what do you envisage it would mean to the world given the new technology being developed? Does it revolutionize an industry, take a market share of another, or open up a whole new sector in itself? In my opinion, Tau as a software will be able to open up new resources for people to use and create in the software that is capable. So I think we'll open up entire new markets, entire new ways of doing things. For example, the way that we communicate, being able to communicate in the reasoning ability of Tau allows us to have discussions at large scale. It allows us to, for example, even change the way we vote. It allows us to capture knowledge and deduce new facts from knowledge. And, for example, you could have scientific research companies, instead of going out and doing the research themselves, they could go and buy the research of much smaller entities, formalize that knowledge and deduce new facts from that and go in and sell that. So you can get entirely new industries just from the capabilities of Tau. That's not even mentioning the decentralized aspects of Tau. So I see massive, massive change once this is fully fleshed out and into the market. The next question is from Marco, and he asks, is it possible to compress anything describable by the Tau language more than Tau actually does? Or have you reached the theoretical limit? Is it the ultimate compression?
Well, for one thing, Tau does not intend to reach anything close to ultimate compression. And for another thing, there are strong theoretical reasons to believe that ultimate compression is not even possible. Maybe it doesn't even exist in theory, but there is a Chaitin incompleteness theorem that says that it's basically impossible to reach the best compression. So this is going to be ongoing effort, how to encode data better and better, but I have no reason to believe we will ever reach any theoretical limit.
And the last question from Marco is, in TauNet, will cryptography be offloaded to a conventional implementation?
Yes, well, in principle, but only in principle. Hash functions or one-way functions are constructed in a way that it's going to be impossible to do it in a logical framework like Tau, because if you could do it, then you could break the cryptography. And therefore, let's say in a blockchain setting of Tau, the hashes will be computed from the outside, hashes, signatures, without implementing them directly in the Tau language, because this will just lead to impossible situation, to complexity that is completely out of scope.
All right. And the next question is from Sir Andrew, and he asks, hi, Ahad, about the context of knowledge representation and atomism Boolean algebra. In the concept related to the example, I like chocolate, do we just need to define the relationship like between the two, and Tau will know I like chocolate without explicitly defining what is I and what is chocolate? The meaning of I and also chocolate can be broken down into infinitely many meanings. Defining the relationship like between I and chocolate is the main thing. By focusing on relationships and constraints within the atomless Boolean algebra framework, we can effectively capture and reason about knowledge in a flexible and scalable manner, without the need for exhaustive definitions of every concept. Is my understanding correct? Thank you.
Regarding atomless Boolean algebra, there is a difference between whether the language makes an atomless Boolean algebra or the objects that the language define make an atomless Boolean algebra. And we are about the first option. So when you say eye or chocolate, it is not necessary to be able to break them to infinitely many parts. They can be one part. But the language makes an atomless Boolean algebra because every sentence can speak only about finitely many concepts. And you can always create a sentence that speaks about one concept that the other sentence didn't speak about. So the language can be broken, but it got nothing to do with the objects themselves. For another thing, the KRR abilities of the Tau language as for itself is for now very limited. And it's an ongoing effort by us to enhance the knowledge representation abilities directly in the Tau language. However, the Tau language, as we already know very well, is a language extension mechanism, and that's the reason we work on the two-variable fragment with counting. This is a very good knowledge representation language, so it can be seen like a two-layer design where we have the two-variable fragment with counting when you can do significant KRR, and on top of that we have the Tau language.
And the last question from Sir Andrew is, could you define what topological sorting and traversal mean? And are they the tools used to infer new knowledge in Tau? Thank you.
Topological sort, in the case of a direct acyclic graph, is just a linear ordering of the vertices in such a way that if we have an edge from vertex Q to vertex V, U appears first than V. That's for the topological sort question. Regarding traversal, it's just usually a way to define how we visit all the nodes of a graph or a tree or whatever. Okay, so it's just a way to traverse all the possible vertices and edges in a direct acyclic graph. Those are not the tools that we use to infer new knowledge in Tau, because at the end, in the Tau language, we use direct acyclic graphs to represent the formulas that we are working on. And inferring new knowledge will imply to deduce things from those formulas, and it's not the main purpose of the topological sort or traversal. Topological sort is one possibility that we are thinking, just to optimize or to parallelize the rewriting system. But that's all. Thank you.
All right, fantastic. David, thank you so much for your questions, guys. And that about wraps it up for the Q&A of April 2024. And we'll see you on Telegram, Twitter, Reddit, and all other socials. Cheers. Bye.